Good morning students. We are discussing data structure chapter. In that yesterday's class we discussed searching. In the searching, one type of searching we have completed, that is linear search. The linear search is also called as sequential search because the element of the searching process taken from the beginning till the end sequentially, one after the other. Hence, it is also called as sequential search. In the last class, we discussed the program number 1 contains the concept of linear search along with traversal concept. Both it included for the program number 1 to find, that means write a program to find frequency of present of an element in the given array. Suppose if the array size is n equal to 5, then we need to enter 5 different elements. 2, 3, 2, 5, 6. My searching element is 2. I should search from the beginning till the end of the list exactly once. Also, I should find how many times the searching element 2 present in the list. Here, once we got the element occurrence, then I should increment my frequency counter by 1. Frequency counter by 1. If the element occurs again, I should increment the counter. See, according to this element, so the element 2 present 2 times. So finally, I should get the result element 2 occurred 2 times. Suppose if I try to find element 12, is there element 12 in the given list? It was not there. That time your frequency count should be 0. Frequency count should be 0. Then if the frequency count is greater than 0, then the element is found. If it is less than 0, then the element is not found. Hence frequency counter first initialized to 0. Then if the element count present, then it is going to change the value. If it changes means element occurred. If it remains 0 means then element is not found. Element is not found in a given list. According to that element 12, there is no change in the frequency count, then the element is not found. Okay, so this concept we are implementing with the lab program 1, finding the frequency. So, for this program we need only 2 header files. Hash include iostream.h, then hash include conio.h, and class definition followed by class name frequency. Class name is frequency, and declare the variables under private as a data member. So here we need array size, array elements, index I, and the counter frequency. These are along with, so first searching element, then frequency counter. Then public, declaring the member functions, void input data, then void find frequency, here I have used underscore, find frequency, then void output data. So these are the member functions declared within the class. Those functions we are defining outside the class with the syntax called return type is a void, class name frequency, scope resolution operator, member function name, input data. So what are the inputs I need? Array size, array elements, then searching element. Cout, enter array size. So you need to accept the value for n, then cout enter array elements. Enter array elements. So here we need to accept the array elements with one for loop because one dimensional array. Array index starts with 0 to n minus 1. 0 to n minus 1. I plus plus. Then C in, accept the value with the index a of I. Then C out, enter searching element. Enter searching element. Which element need to be searched, that value you need to give. So C in, enter the element. So this is your input. Then we move for the processing part, that is find frequency. Return type, class name, scope resolution operator, function name, find frequency underscore, find frequency. Here first initialize the frequency counter by 0. Frequency counter by 0. Then traversal begins with I equal to 0, I less than or equal to n minus 1, I plus plus. Here we are applying linear search concept. In the for loop we are applying traversing concept. If the searching element is equal to the given a of I, then increment the frequency count by 1. If the frequency count incremented, only one statement, no need to add the flower price. Increment the frequency count up to where? Up to 0 to n minus 1. Once all the elements searching completed, whatever the value remains in the frequency. This is plus plus, not a TT. That means frequency equal to frequency plus 1. Can be written as plus plus. Okay. Then write the output function void frequency scope resolution operator output data. Output data. Then if frequency greater than 0, if frequency not equal to 0, please remember here only greater than 0. If it is 0, element not found. If it is greater than 0, then only element found. See out, element present or occurred present frequency times. Present 2 times. So only one statement, no need to add the endl. Else see out a particular searching element not found. Not found. So this is your output. Then we will write the main function void main, declare the object declaration with a class name. Declaration of the object with a class name. Then CLRSCR, it may be first statement or it may be second statement, doesn't matter. Then obj dot input data. First invoke the input function, then invoke the find frequency function, then invoke the output function called output data, then get ch, then end of the. So this is your first lab program. So execution of this video I send along with a PDF. Take a printout and keep it with you. That will help you to write the lab programs in the record. Okay students, so here these are the data members, these are the member functions declared within the class, hence it is class definition with the class name, frequency. These declaration of the member function, definition done outside the class with the scope resolution operator, syntax, return type, class name, scope resolution operator, then the function name, order of the writing the function, and invoking method is properly. So the input, output, frequency, anywhere you can write, but the invoking method is compulsory. First input, then process, then output. Find frequency is a process. Okay, so here cout enter array size, cout enter array elements accepted with a single for loop with a single to one dimensional array and searching element. Did you notice that up to here? So this complete part is common for program number 1 and program number 5. This complete part is common for 1 and 5. 1 and 5. And up to here is common for program number 2 also. And one more statement it is going to add, that is called position. And these two statements was eliminated in a delete program and only position it will be there. Up to here it is common for program number 4. So you need to do that comparison properly so that easily you can prepare program number 1 to 5. So almost output statement for 3 programs it was same, 2, 3, 4. Program number 1 and 5 somewhat similar this. But here it is location greater than or equal to 0 in binary search. It is frequency only greater than 0. So then element found at location we are giving and at else part it is same. For program number 1 and 5. Both are searching concept. Frequency. First we initialize the frequency counter by 0. And traversal concept from 0 to n minus 1. This is comparison from the linear search concept. So both we have included. Which concept included in the frequency of the program? Whoever will get the program number 1. This is the first Viva question. Here we included the concept called traversal and linear search. Traversal and linear search. Okay student? Where you declare the object, we declare the object here along with the class name. These are function invoking method. How we are invoking? We are invoking along with the object name with a dot operator followed by function name. What is the order? First input, process, then output. Okay, we'll continue. So program number 1 with the linear search concept completed. Then we'll move for the binary search now. We'll continue now with the binary search. What is a binary search? It is also finding an element in the given array with only n by 2 comparisons. Linear search, it is also finding an element sequentially with the n comparisons. Here it is n by 2 comparisons. And linear search will work for any kind of element. It doesn't matter the elements should be sorted or unsorted. But in binary search, array elements must be sorted. It compulsory sorted. This your process of binary search will applicable only for the sorted element. This is the first Viva question. What is the condition for binary search? The condition for binary search is array elements must be sorted and we are doing only n by 2 comparisons, not n comparisons. Hence, we are comparing only n by 2. It is faster compared to linear search. Linear search compares n number of comparisons for unsorted elements. Linear search n by 2 comparisons for sorted elements. There is some conditions of binary search. Conditions or rules of binary search. Your binary search will be applicable only from the lower bound to upper bound, called high pointer. This is called upper bound and this is called lower bound. If the low value is always less than or equal to the high, then only you can apply the binary search. If this condition was satisfied, then we are finding the mid element first. What is the mid? Lower bound value plus upper bound value divided by 2. You will get the mid value. Then we are comparing our first searching element is equal to the given mid element. If this condition was satisfied, then we are changing the location equal to mid. Location equal to mid. If the searching element is not a mid, for example, I have taken here n equal to 5, 10, 20, 30, 40, 50. So I have taken here 10, 20, 30, 40, 50. So this is your A of 0, A of 1, A of 2, A of 3, A of 4. What is a lower bound? 0 is a lower bound, 4 is your upper bound called high pointer. Check the condition. Is it a low less than or equal to high? So what is a low? 0 is less than or equal to 4. Yes, the condition is true. Then find the mid value by low value plus high value divided by 2. What is a low value? 0. High value 4 divided by 2. What you will get? You will get 2. What is the mid value you got? Mid value we got as a 2. Here 2 is index. It is called index. What is A of mid? There is a difference between only mid and A of mid. Mid is 2 means index value is 2. Index. A of mid means the value present in the A of 2. What is the A of 2? That is 30. There is a difference between only mid and A of mid. Mid means index value. A of mid means content present in the particular index. If my searching value is equal to the mid element, suppose if my searching element is 30, then the searching element is equal to A of mid. Yes, both are true. That means both the values are equal. When the condition is true, change the location equal to mid value. Then element 30 found at location 2. Suppose if my searching element is 40. Is it 40 equal to 30? Condition is false. If the condition is false means I should check whether I should traverse from the midpoint towards the right hand side or towards the left hand side. If the elements are greater than the mid, traverse only for the right hand side. If the element, my searching element is 20, is less than the mid element, traverse towards the less than side for the left hand side. Did you got it? So, depending on the searching element, traversal has to be continued. Then, only half of the elements we are comparing, hence it is n by 2 comparisons. N by 2 comparisons. Did you got it? If the searching element is greater than the mid, only half of the right side, that means in the given list, only half of the array we are going to compare. Then the remaining half for the left side with the less than side we are not going to compare. That is the advantage of linear search, binary search. Hence we need sorted list to do this particular algorithm. Then, if this is false, then control has to move for the else part. In the else, again it is going to check whether the given element is greater than the A of mid. If it is true, then I should change the low pointer equal to mid plus 1. Then if the element is greater than low pointer, I need to shift to mid plus 1. What is the mid we got? We got a 2. 2 plus 1, it will be changed the low value. Always the low value should be less than or equal to high value. Is there the condition? Yes, 3 is less than or equal to 4. If that is condition, again this will be repeated. From where? From here it is going to be repeated. Hence we need to execute the set of statements repeatedly. Then this condition has to be tested with a while loop. This you need to test with a while loop. Did you got it? Suppose my searching element is 20. Then I need to shift my high pointer, not a low pointer. That time low pointer remains 0. Low pointer remains 0. Now the searching element is 20. Then is it 20 greater than the A of mid 30? No. Then again I should check with one more else part with the condition. Element is less than the A of mid. If it is less than the A of mid, that time we need to traverse only for the less than side with the left hand, not with the right hand side. That time you need to change your high pointer with the mid minus 1. What is a mid? 2. 2 minus 1? It is a 1. So now also please check 0 is less than or equal to 1. This condition has to be satisfied. Then only traversal will be continued with the while loop. Then which pointer we need to change? We need to change high equal to mid minus 1. So again this will be continued with the while loop. Did you got it? Again, see condition will be satisfied with this one only. So which part we need to traverse, that will be decided by your this condition. If it is greater than, traverse only for the right hand side. If the elements is less than, traverse only towards the left hand side. Okay, so only changing the pointers, again it will be repeated with the while loop. So this kind of process is called as binary search. Binary search, that means decision will be done with the divided the array elements by 2 parts. Dividing the array elements with the 2 parts, that is called your n by 2 comparison, not with the n comparisons. Did you got it? So shall we write the algorithm? Then we will move for the tracing of the program, algorithm. Tracing of the algorithm, we will do it in the next class. Today I will write only the algorithm part. So algorithm binary search. Step 1. First we need to initialize the location equal to minus 1. As we know in the linear search, if the element found means it should be found within 0 to n minus 1. If the element is not found, location will be remains minus 1. So the same concept we applied in the linear search also. Here also, if the element found means it should be found between 0 to n minus 1, then only the value is going to be changed with the mid value. Otherwise, it will be remains minus 1. Hence, location equal to minus 1. First time, your low pointer should be initialized to 0. So, low has to be 0. And your high pointer called upper bound has to be initialized to n minus 1. These 3 initializations are compulsory. What is that? Location pointer for the minus 1. And low called lower bound 0, high called upper bound n minus 1. Then we are moving for the step number 2. In the step number 2, while loop. We are checking the condition with a while loop. Your low value is always less than high value, then only process will be continued. If it beyond that, that means it reaches to greater than or it reaches to less than that, then you are not going to process the binary search. Then we are going to find the mid value. Mid equal to low plus high divided by 2. Divided by 2. Then we are doing the comparisons. If the searching element is equal to the A of mid, then location will be changed to mid value. Then stop, go to the next step. Suppose if the condition is false, again we need to check the condition. If the searching element is greater than the A of mid, if it is greater than, we are traversing only towards the right hand. That time left hand side low variable has to be bring to the right hand side next to the midpoint. Next to the midpoint means mid plus 1. We need to bring the low pointer to the next to the mid. Next to the mid means mid plus 1. Suppose if this condition is false, we no need to check the condition. Then the element is less than. That time you are going to change the which pointer? High pointer you are going to change. High equal to mid minus 1. Mid minus 1. Then end if, end while, end of while. Then next step we are moving. So I am writing the next step here, student. That is step number 3. If you want, you can add here step number 3, step number 4. So if it is step number 4, then it is step number 5. So where we are moving? Go to step number 5. Go to step number 5. So what is the condition? Here, if particular location greater than or equal to 0, then element found in the 0 to n minus 1. If the element found in the n minus 1, it is possible for 0. Hence it is equal to 0. Print element found at location. Element found at location. Else print element not found. Element not found. And if the last step, exit. Step number 6. Did you got it? So repeatedly we are going to check in the while loop. If the low value, that means always the lower bound value should be less than the upper bound value. So upper bound we have taken the variable name called high. Lower bound we have taken the variable name called low. So there are many possibilities. LB can be written as either a low or BEG called a beginning element. Upper bound or your high value or end value. Any of these 3 pointers can be used. Either you can take LBUB, low or high, beginning or end. So any of the pointer can be taken. So just the name of the variable it is going to be changed. That's all. There is no concept changing. Only the variable name it is going to be changed. Either LB, low or beginning. Everything is same. Either upper bound, UB, high or end point. All these are pointers. All these are pointers referred for index. Referred for index. Instead of I or J, here we have taken UB and LB. Okay. So depending on the pointers, we are going to trace the program. First we are going to check LB is less than or equal to UB. If that condition satisfied, we are dividing the array into 2 parts. The n elements divided into 2 parts. Hence we are going to compare only n by 2. Then we are comparing with the first mid value. There is a difference between mid and A of mid. This is very important to know. This is index This is the value present in the index. Value present in the index. That means if the mid is 2 means A of mid is nothing but A of 2. Content present in the A of 2. 2 is a index. A of 2 is a content present in the 2. If you know that one, then it is easily understand for you. So please understand the students here. First we are comparing with a mid element. If that condition satisfied, we are initializing the mid index into the location. Otherwise, we are checking whether we should traverse for the right hand side or for the left hand side. When we are traversing for the right hand, if the element is greater than, we are traversing for the right hand side. If the element is less than, we are traversing for the left hand side by changing the low and high. Depending on it. If it is greater, change the low value to the mid plus 1. Mid plus 1. If it is less than, mid minus 1. Which pointer? High pointer has to bring towards the left hand side. If it is greater, then low pointer has to bring the mid next value. Depending on the less than and greater than, we need to shift the elements, that is called pointers, low and high pointer. Again this process will be repeated in the while loop again with a comparison. Okay, so we trace the program values. The tracing is compulsory. We are going to trace 6 different possibilities. If the element is 10, 15, 20, 25, 30. First, we need to compare with a mid value, exactly mid value, and one problem with a greater than the mid value, one problem with a less than the mid value, one with greater than not found, one with less than not found, and one with towards the left hand, again towards the right hand. Left hand, in the left hand, once again with the right hand side. This traversal, 6 different possible programs we need to be discussed. So after that, we'll write the program of that. Okay students, we'll continue in the next class, tracing or problems related to binary search. Thank you students.